In this episode of Human AI Mashup, I'm joined by two AI collaborators as we dive deep into my book, Empowering Leaders with Cognitive Frameworks for Agentic AI, now available worldwide on Amazon. Together, we unravel how leaders can leverage the transformative power of Agentic AI to redefine strategy, foster innovation, and achieve purposeful outcomes in a rapidly evolving world. Get ready for an engaging exploration of ideas designed to empower leadership and spark meaningful change. Let's begin.
Welcome to this deep dive into agentic AI. Looks like we've got chapters from a book here all about building specialized AI systems.
Bro.
So we're going beyond the AI basics, right? You're interested in the nuts and bolts of designing intelligent agents, especially ones tailored to specific industries.
Yeah, and the book really emphasizes how to build these agents responsibly. Lots of discussion about sustainability and creating AI that works in a human-centric way.
Right, not just building cool tech for the sake of it.
Mhm.
We're talking about the impact, the big picture. So our mission today is to unpack those core principles and see, how they actually play out. The book starts with a really interesting analogy comparing human cognition to AI agent design.
Yeah, it uses a chef as an example. How a chef perceives ingredients, remembers recipes, applies knowledge to create something new. It's not about just mimicking human actions, it's more about understanding those underlying processes.
Right, so we're not just teaching an AI to chop vegetables, right?
Mhm.
We're teaching it the why behind it. Like
Right.
a chef understands which flavors work together. That leads to a much more adaptable system, I imagine.
Exactly. And that brings us to the evolution of AI. We're past those basic rule-based systems. Now we're talking about AI that can learn, adapt, even exhibit a degree of autonomy. That's what sets agentic AI apart, right?
Yeah.
It mirrors those higher level functions we see in humans.
I see the connection now. We're talking about AI that can, not only do tasks, but understand the nuances of a field, like healthcare or finance.
Exactly. The book calls it vertical agentic AI. It's about creating AI that's deeply specialized, almost like an AI expert in a certain domain. You can imagine a healthcare AI assisting doctors with personalized treatment plans, or a legal AI drafting contracts, tailored to specific jurisdictions.
That's wild. It's like having a team of AI specialists all at your fingertips.
Hmm.
But what happens when you have multiple AI agents, each with their own expertise? How do they work together?
That's where the concept of multi-agent systems comes in. Think of it as a network of AI agents, each with their own skill set, collaborating to solve a complex problem, like pooling their knowledge to achieve a goal.
I see the potential, but it also sounds like a coordination nightmare. How do you ensure they're all on the same page, working efficiently?
Well, the book highlights some challenges there. You need clear communication between agents, you need ways to resolve conflicts, and ways to ensure overall efficiency, right? It's like managing a team of really bright, independent minds.
Okay, makes sense. Now, I'm curious about the technical side. How do you build an AI agent? The book mentions a 7-layer technical stack. Can you walk me through that?
Sure, one of the key layers is perception and data ingestion. That's about focusing on data quality and fairness right from the start. And then there's memory, which provides context and continuity. Think of it as an AI's version of past experiences.
So the AI isn't just reacting to new info, it's using its memory to make better decisions. That makes sense. What about the decision-making layer? How does an AI agent actually make a choice?
That's where it evaluates different options based on its goals, the available information. Transparency is key here, making sure we can understand how it arrived at that decision. And then there's action and execution, where the AI actually interacts with the world based on that decision.
So it's not just thinking, it's doing. The book also talks about prompt engineering. What's that and why is it so important?
Prompt engineering is all about giving clear instructions to the AI in a language it understands. A well-crafted prompt can really guide the agent, reduce ambiguity, and improve accuracy, especially for, really specialized tasks.
Got it. So we have these powerful AI agents that can learn, adapt, even work together. But what about the bigger picture? How do we ensure this technology is used responsibly, ethically?
The book dedicates a whole section to responsible and sustainable AI. It talks about transparency, fairness, accountability in these AI systems. Use examples like bias detection, say in hiring, or ethical decision-making for self-driving cars.
So making sure that as this tech advances, it's actually benefiting society. The book also goes beyond just ethics, right? It talks about sustainability, too.
Yes, definitely. It emphasizes energy-efficient models, things like carbon-aware workflows, even circular resource management, sustainability from the ground up.
It's great that the book takes such a holistic view. It's not just about the tech itself, but the impact it has. Now, I'm really curious to see how these concepts play out in real-world situations. You mentioned some mind-blowing applications earlier.
Oh yeah, there are some incredible examples. Let's take marketing. Imagine AI agents handling everything from content creation to targeting, even real-time optimization. Analyzing data, identifying patterns, creating super personalized campaigns.
So instead of broad-stroke marketing, you're using AI to be hyper-targeted. What about other industries? What else stands out?
Well, disaster response is another one. Imagine a swarm of drones, each with its own AI, right? Being deployed to a disaster zone. They could map the area, locate survivors, even deliver aid, all while coordinating with each other.
That's incredible. It's like something straight out of a sci-fi movie.
Hmm.
And speaking of sci-fi, the book also touches on emerging trends in AI, right? Pushing the boundaries even further.
Oh, absolutely. We're seeing things like agent marketplaces, where developers can buy and sell pre-trained AI agents. There's research into quantum enhanced intelligence, which could lead to AI that's, well, orders of magnitude more powerful. And then there's the idea of self-evolving agents, which is still pretty out there. But the idea is that these agents could design and improve themselves.
Okay, that's both exciting and a little bit scary. Sounds like the future of AI is going to be a wild ride. But of course, with all this potential, there are challenges too, right? What are some of the obstacles we face as we develop these powerful systems?
Well, one of the big ones is navigating cultural nuances. As these agents are used around the world, they need to be sensitive to different norms, different values. An AI that works great in one culture could be totally inappropriate in another.
That's a really important point. You can't just assume one size fits all. What other challenges come to mind?
Cybersecurity is a huge one. As AI systems become more integral to critical things like power grids, transportation, the stakes get much higher. We need to develop robust ways to protect these systems, to ensure safety and privacy.
And of course, the world's constantly changing. New tech, new trends, new challenges popping up all the time. AI systems need to be adaptable, right? Able to learn and evolve.
Definitely. That adaptability is key. We have to move beyond static, pre-programmed AI and build systems that can learn and adjust, as the world changes around them.
So it sounds like the future of AI is going to require a lot of careful thought, a lot of planning. But I have to say, the potential benefits are so incredible that it's got to be worth the effort.
I completely agree. The key is to approach it responsibly, ethically, making sure AI serves humanity and helps us build a better future. And that's where all these different architecture patterns and design principles really come in.
Speaking of architecture patterns, I'm particularly intrigued by this one, the Retrieval Augmented Generation Architecture. It's called RAG for short. It combines the power of, retrieving information with generative AI, which is pretty cool.
Ah, yes, RE. It highlights how dynamic knowledge integration can really elevate an AI's capabilities. It basically combines the power of retrieving specific information with the creative power of generative AI.
Okay, I'm all ears. Tell me more.
So imagine an AI agent that needs to, say, answer a complex question. Instead of relying on its pre-programmed knowledge alone, a RAG-based agent can access external sources, pull in relevant information in real time.
So it's like having access to a massive library, a knowledge base that the AI can search through.
Exactly, and not just any library, but one tailored to the task at hand. And it can even use these semantic search techniques to really understand the meaning of that information.
That's really impressive. It's like having a research assistant on call, 24/7. So how does this actually work in practice?
Well, the RE process can be broken down into three main phases: retrieval, augmentation, and then generation.
Okay, I'm following along. So what happens in that first phase, the retrieval phase?
In the retrieval phase, the AI gets a query, a task, whatever it might be, and it uses that input to actually search for relevant information in various sources.
So if I asked an AI agent about the latest, I don't know, quantum computing breakthroughs, it would go out and find articles, research papers, all that stuff.
Exactly, and it wouldn't just be doing simple keyword searches. The AI is using sophisticated algorithms to understand your question, the context, to pull the most relevant information.
Wow, that's incredible. So what happens next?
Well, once it's gathered that information, it moves on to the augmentation phase. This is where it gets interesting.
Okay, tell me more. I'm hooked.
So in this phase, the AI doesn't just use the information as is, it analyzes it, integrates it with your original query.
So it's not just finding information, it's understanding how that information relates to the problem.
Exactly. The AI is using its knowledge and reasoning abilities to connect the dots, create a more complete understanding of the situation.
I see. So it's almost like the AI is building a custom knowledge base just for that specific task.
And that brings us to the final phase, the generation phase. This is where the AI, now armed with all this new knowledge, actually generates a response, completes the task, whatever it might be.
So to go back to that quantum computing example, the AI would use all that gathered information to give me a comprehensive overview, like a summary of the latest breakthroughs.
Exactly, or even go further than that. It could generate reports, creative content, all informed by that specific knowledge it's retrieved.
This is amazing. It's like the AI isn't just spitting out information, it's actually using it to create something new.
Precisely. That's the power of RAG. It bridges that gap between just finding information and actually generating something valuable, something new.
I see why you're so excited about this. It sounds like RGRAG has huge potential in all sorts of fields.
It really does. And the book gives some fantastic examples of how it's being used today. For example, in healthcare, our GRAG-powered agents can help doctors, retrieving guidelines, patient records, the latest research.
So instead of doctors having to search through tons of data themselves, they can rely on these agents to pull up what's relevant,
Right.
saving time and potentially improving care.
Exactly. And it's not just healthcare. Our guy is being applied in law, education, e-commerce, finance, you name it.
Wow, the possibilities are truly mind-blowing. But let's dive a little deeper, technically speaking.
Hmm.
How does RAG fit into those 7 layers of the technical stack we talked about earlier?
Great question. RGRAG interacts with multiple layers, showing how seamlessly these concepts work together. It starts with the perception layer, where it processes the user input, transforms it into something the AI can use for retrieval.
So the perception layer is all about understanding what the user is asking and making it digestible for the AI agent.
Precisely. Then comes the memory layer, which is crucial for efficiency. It stores frequently retrieved data or historical context. Think of it like in customer support, the AI can remember past interactions, so it doesn't have to keep retrieving the same info over and over.
So the AI can actually learn from past experiences and become more efficient over time.
Exactly. And then there's the knowledge processing and reasoning layer. That's where RA really shines. This is where the AI takes that retrieved data and combines it with the user's question, the context.
So it's about making sense of the data, connecting the dots, and turning it into something meaningful.
Exactly. Then you have the decision-making layer, where the AI evaluates everything and decides what to do next.
So it's like the AI is weighing its options, choosing the best response, right?
Right. And once it's made a decision, you have the action layer, which generates the output, whether it's a text answer, a recommendation, or an action in the real world.
So it's really a collaborative effort across all those layers, with IA kind of pulling the strings.
Absolutely. And we can't forget about the feedback layer. This is crucial for making sure the RAG process keeps improving. The AI takes in feedback, analyzes performance, and makes adjustments to retrieval strategies, reasoning methods, all of that.
Wow, this is incredible. It sounds like RA is a really sophisticated approach, a potential game changer for lots of industries. But I'm also curious about potential downsides. Are there any risks we should be aware of?
That's an important point. While RAG has incredible potential, we need to be mindful. One concern is bias. If the sources used by the AI agent are biased, then the AI's responses could be biased too.
That's a valid concern. So we have to make sure the AI is getting its information from diverse, trustworthy sources.
Absolutely. And it's not just about the sources themselves. The AI's algorithms need to be designed to mitigate bias as well.
Makes sense. What about computational resources? RAG sounds pretty demanding. Are there any environmental concerns there?
That's another important consideration. R can be computationally intensive, especially with large data sets and complex models. All that processing power takes energy.
So we need to think about the energy efficiency of these RA systems.
Definitely. Developers need to optimize algorithms, use energy-efficient hardware, and explore techniques like federated learning to reduce that environmental impact.
It sounds like there's a lot to consider when implementing RA responsibly.
There is, but the potential benefits are so huge that it's worth the effort to get it right, to make sure we're using this powerful technology for good.
I totally agree. This deep dive into ARG has been incredibly insightful. Thanks for breaking it all down so clearly. But I'm also eager to learn about some of the other architecture patterns you mentioned earlier. What about event-driven architectures? How do AI agents react to events happening in real time?
Event-driven architectures are fascinating. It's about creating AI that's truly responsive, truly adaptable. Let's dive into how that works and what it means for the future of AI.
I'm ready. Tell me everything.
Event-driven architectures, they really transform these AI agents,
Mm.
From just observing to actually responding, taking action. It's about designing systems that can react in real time, whether it's a user doing something, a sensor, picking up a change, whatever it might be.
So it's AI that can keep up with the real world, right? Always on,
Yeah.
always ready to react. Can you give me an example of how this works, like in a real situation?
Sure. Think about a self-driving car. It needs to react instantly, right? A pedestrian crossing the street, another car changing lanes. Event-driven architecture is perfect for that because the AI can process those events as they happen and, adjust what it's doing.
Okay, that makes sense for something like autonomous driving. But what about the technical side? How do you design an AI agent that can handle these events, these real-time changes?
Well, you start with the concept of events. An event is any change, any signal that something happened. For our self-driving car, it could be a pedestrian stepping onto the road, a traffic light turning red. These events can come from all over, sensors, other AI agents, even a human driver doing something.
So the AI is constantly getting this stream of information about its environment. What happens then? How does it decide what to do with all that data?
That's where those layers of the technical stack come in, right? Remember those. The perception layer acts like a filter, so the AI isn't overwhelmed with irrelevant stuff. It picks out the events that matter, the ones it needs to focus on.
Right, separating the important stuff from the noise. What about memory? How does that play into all of this?
Memory is crucial because it lets the AI understand this new event in relation to, well, past events. Like with our self-driving car, let's say it encounters a pedestrian. Well, it needs to consider its current speed, the distance to that pedestrian, and if it's, encountered pedestrians before in similar situations.
So it's using its memory to say, okay, I've seen this kind of thing before, and here's how I reacted last time.
Exactly. And that memory layer also helps the AI learn. By storing all those past events, it can refine its responses, become more efficient over time.
So it's constantly learning from experience, just like a human driver would. Once the AI has processed that event, what's next? How does it figure out what action to take?
That's where we get to the knowledge processing and reasoning layer. The AI analyzes all that event data, right?
Yeah.
And uses what it knows from memory, plus any pre-programmed knowledge about, driving in this case.
Is piecing together the puzzle, figuring out what this event means and what it should do about it.
Exactly. If it's a pedestrian crossing, well, the AI needs to understand that means it needs to slow down, maybe stop to avoid an accident. It might also consider things like how fast the pedestrian is moving, are there other cars around, what are the traffic rules, all of that.
Wow, that's a lot going on. Much more than I realized. Okay,
Yeah.
so the AI analyzes the situation, it understands what's happening. How does it actually choose what to do?
That's the decision-making layer. This is where it weighs its options, thinks about the potential outcomes, and picks the best course of action. And of course, it has to follow any safety guidelines or ethical rules.
That's a big responsibility. How do you ensure an AI agent is making the right decisions, especially in these real-time situations?
That's one of the big challenges, right? The book talks a lot about building safeguards, having oversight, things like human-in-the-loop systems where a person can step in if needed, or maybe having the AI explain its reasoning so we can understand how it's making those decisions.
Okay, transparency, accountability, those are crucial, especially as AI gets more powerful and more independent. So the AI makes a decision. What's next? How does it actually do something in the real world?
That's the action execution layer. This is where the rubber meets the road, as they say. The AI interacts with the outside world, maybe by sending commands, controlling motors, things like that.
So with the self-driving car, this is where it actually hits the brakes or turns the steering wheel.
Exactly. And this layer has to be able to handle surprises too. What if the brakes fail or a car suddenly swerves in front of it? It has to be able to adapt and adjust.
That's pretty amazing. It sounds like these event-driven architectures are really well suited for these dynamic real-time situations.
They are. And the book talks about some other interesting examples too, like they're being used to develop these smart energy grids, systems that can adjust how electricity is distributed based on real-time demand and supply.
That's a really cool application, using AI to solve real-world problems. Any other examples that stand out?
Healthcare is another big one. You can imagine using this to monitor patients remotely, and alert doctors if something seems wrong. Wearable sensors that track vital signs, and an AI that can detect maybe early signs of a heart attack, something like that.
That's incredible. It's amazing to see how this technology can be applied to so many different challenges. But I also have to ask about the potential downsides. As these systems become more common, are there risks, ethical considerations we need to be aware of?
Of course. One of the big ones is reliability. These systems have to be really robust. If an AI agent makes a mistake, especially in a real-time situation, the consequences could be serious.
Yeah, that's a valid point. How can we make sure these systems are safe, trustworthy?
Testing, testing, testing. You have to put them through rigorous tests in all sorts of scenarios simulated in real world to find any weaknesses.
So it's like testing a self-driving car on a test track before you let it loose on real roads.
Exactly. And even after they're deployed, you need to monitor them closely, make sure they're working as expected. Just like any complex system, they need maintenance, attention.
Right. You can't just set them and forget them. And I imagine there are also broader societal impacts to consider, right? How will these systems affect jobs, privacy, security?
Absolutely. Those are all important questions. As we develop and deploy these technologies, we have to think about the big picture, not just the technical aspects, but the human and societal implications as well.
It's a lot to think about. But it seems like the potential benefits are so huge that it's worth the effort,
Hmm.
to get it right, to make sure this technology is used for good.
I agree. The key is to be thoughtful, responsible, and to make sure this technology serves humanity. And speaking of responsibility, the book talks about sustainability in AI, and one architecture that really stood out to me was memory-centric architectures. They focus on using memory to make AI more efficient, more sustainable. Can you tell me a bit more about how that works?
Yeah, I'm curious about that too. Memory-centric, it sounds like it's all about giving AI a good memory so it doesn't have to relearn things constantly.
You got it. By giving AI access to a vast store of information, it can avoid all that retraining and recalculation, which uses a lot of energy.
So it's like giving the AI a mental library it can refer to instead of having to start from scratch every time.
Exactly. And that saves energy, which is good for the environment. And it makes the AI more adaptable, too. It can learn from its experiences and apply that knowledge to new situations.
So it's a win-win. More efficient AI and a smaller environmental footprint. Can you give me an example like how this might be used in the real world?
Sure, think about a smart home system, one that manages energy use. With a memory-centric architecture, it can learn the homeowner's habits, like
Hmm.
when they're usually home, what temperature they prefer, and then optimize things like heating and cooling to save energy without sacrificing comfort.
That's really cool. It seems like such a simple idea, memory, but it can have such a big impact.
It can, and the applications go far beyond just homes. Healthcare, transportation, manufacturing, all sorts of areas where this could really change things.
I'm really starting to see how memory-centric architectures could lead to like a whole new level of AI, more efficient, more adaptable, and better for the environment. But can you get a little more technical? Like how do you actually design an AI system with this kind of architecture?
Well, it starts with the type of memory system you use. Just like humans, AI can have different kinds of memory, right? Short-term memory, sometimes called working memory, that's for information needed right away. And long-term memory, that's for storing knowledge, past experiences, things like that.
So it's like having different mental compartments for different types of information.
Exactly. And the capacity of those compartments can vary depending on the AI and what it needs to do. But how does the AI actually use that information? That's the key.
Right. It's one thing to store information. It's another to actually be able to use it.
Exactly. That's where those other layers of the stack come in, remember? Perception layer filters new info, decides what to store. The knowledge processing and reasoning layer uses that stored information to understand things, make decisions. And the decision-making layer uses memory to, well, make those informed choices.
So it's a team effort, but memory is the key player, guiding everything the AI does.
Exactly. Memory isn't just passive storage, it's an active part of how the AI thinks.
That's really fascinating. I can see how this leads to a much more sophisticated kind of AI.
It can. And the book has some great examples of potential applications. In healthcare, for example, this could let AI personalize treatment plans using a patient's entire medical history and genetic profile.
Wow, it's like having an AI doctor that knows everything about you.
Right. And in education, you could use it to create personalized learning experiences for each student, adapting to their learning style and pace.
The possibilities are amazing.
Yeah.
But As always, there are probably challenges too, right? Risks, ethical things we need to consider.
Of course. One of the big ones is just the volume of information. As AI gathers more and more data, it gets harder to manage it all, to store it, organize it, and find what you need quickly.
So it's a data management problem on a massive scale,
Exactly. We need really advanced systems for indexing and searching all that information.
like a superpowered filing system for the AI's brain.
Yeah.
But what about the information itself? How do we make sure it's accurate, unbiased,
Mm.
you know?
That's crucial. We have to be so careful about bias creeping into AI systems, especially if they're learning from data that already reflects, societal biases.
So garbage in, garbage out, as they say.
Exactly. It all comes down to responsible AI development, being careful about the data we use, and designing systems that can detect and correct for bias.
It sounds like memory-centric architectures are a really powerful tool, but they come with big responsibilities too.
Absolutely. It's not just about building amazing technology, it's about making sure that technology is used ethically and responsibly.
Well said. This deep dive into memory-centric architectures has been really thought-provoking. But you also mentioned swarm-based AI agents earlier. This sounds fascinating. Can you tell me more about how those work?
Oh, yeah, swarm-based AI. It's really cool. The idea is inspired by nature. You know how swarms of insects or flocks of birds work together? You create a system where multiple AI agents, each with their own little piece of the puzzle, collaborate to solve a problem.
So it's like a team of AI agents, all coordinating their efforts, just like a swarm of bees building a hive.
Exactly. And the book highlights some of the benefits of this approach. Swarm-based AI can be really resilient, If one agent fails, the others can pick up the slack. And they can be really good at exploring a problem from all angles, finding the best solution.
I'm intrigued. Can you give me an example of how this might be used in the real world?
Sure, imagine a search and rescue operation, like after a natural disaster. You could send out a swarm of drones, each equipped with cameras and sensors, to search for survivors. They could communicate with each other, share information, and coordinate their search to cover the area quickly and efficiently.
Wow, that's a powerful example. It's amazing to think that AI could be used to help people in such a difficult situation.
And it goes beyond just search and rescue. Think about managing traffic in cities, monitoring crops on farms, exploring the ocean floor, all sorts of possibilities.
The possibilities are endless. But it also sounds like it must be incredibly complex to design and implement these swarm systems, coordinating all those agents, making sure they're all working together.
You're right, it is complex. One of the key ideas in swarm-based AI is decentralization. Instead of having one central control, each agent has a degree of autonomy.
So it's not like having a queen bee telling everyone what to do. Each bee can make its own decisions based on what it sees around it.
Exactly. And that makes the system more robust. If one agent fails, the others can adapt.
That makes sense. But if each agent is only focusing on its little piece of the puzzle, how do you make sure the whole swarm is working towards the same goal?
That's where emergent behavior comes in. You design simple rules for how the agents interact, and then complex, coordinated behavior emerges at the swarm level.
So it's like saying that the behavior of a flock of birds emerges from the interactions of individual birds, even though there's no single bird leading the flock.
Exactly. It's a really cool example of how complexity can come from simple rules.
This is blowing my mind a little bit, but how do you actually build these systems? What does a swarm-based AI system look like under the hood?
Well, the technical details can vary, but the core idea is to create a distributed system where the agents can communicate and coordinate.
So it's like building a network of interconnected AI agents all working together.
Exactly. And each agent in that network has its own sensors, maybe actuators, its own processing power. It can sense its environment, make decisions, and take actions.
So each one is like a mini AI system, but also part of a bigger team.
Exactly. And they have to be able to talk to each other, right? Maybe using wireless networks or infrared signals or even just touching each other.
So they're constantly sharing information, coordinating their actions like little whispers going back and forth.
Right. And all that communication allows the swarm to adapt to changes, explore new things, and solve problems together.
I'm starting to see how powerful this could be. It's like having a team of experts all working together in perfect harmony.
And the book gives some concrete examples. Like in traffic management, you could have swarm-based AI agents controlling traffic lights, rerouting vehicles, all based on real-time traffic conditions.
So instead of those fixed traffic light patterns that never seem to work, You'd have AI adapting to the situation in real time.
Exactly. And that could mean less congestion, shorter commutes, even improved safety.
That sounds fantastic. What about other applications?
Disaster response is another one. We talked about the drones, but you could also have swarm-based AI coordinating teams of robots, search and rescue dogs, even human volunteers.
So creating a super efficient response team that can adapt to, the chaos of a disaster.
Precisely. And the book also mentions agriculture, where swarm-based AI could be used to monitor crops, optimize irrigation, things like that.
So instead of just spraying pesticides everywhere, you could have AI targeting specific pests, protecting the environment.
Exactly. It's a much more sustainable approach.
This is really exciting. It sounds like swarm-based AI has the potential to, well, revolutionize a lot of things.
It does. And as the technology gets better, we can expect even more amazing applications.
I can't wait to see what the future holds. But as with any new technology, there are probably some concerns, right? Things we need to be careful about.
Absolutely. Swarm-based AI is powerful, and we need to make sure it's used responsibly. One of the big concerns is unintended consequences. With so many agents interacting in complex ways, it can be hard to predict exactly how the system will behave.
The classic, what could possibly go wrong scenario.
Exactly. So we need to be really careful about testing and simulation. Before we unleash a swarm in the real world, we need to put it through its paces in a safe environment.
So run virtual experiments, make sure there are no nasty surprises.
Right. And we also need ways to monitor and control the swarm even after it's deployed, just in case things start to go off the rails.
Like a safety switch, just in case.
What about the decisions the swarm makes? If those decisions impact people, how do we ensure they're fair, ethical? That's another big question. We need to make sure the AI is aligned with our values, that it's not causing harm or discriminating.
So it's not enough to just build intelligence systems, we have to build ethical systems too.
Absolutely. Responsible AI is crucial, especially when we're talking about something as powerful as swarm-based AI.
Well said. This has been a really insightful look into swarm-based AI. Thank you for explaining it all so clearly. But you also mentioned another architecture earlier, multi-agent orchestration. That one caught my attention too. Can you tell me more about that?
Of course. Multi-agent orchestration, it's like conducting an orchestra, right? You've got all these different AI agents, each with their own special talents, and you need a way to bring them all together and make them play in harmony.
Okay, I'm getting the analogy.
Hmm.
But how does it work in practice? How do you actually orchestrate all those AI agents?
Well, imagine you're planning a trip, right? You need to book flights, hotels, figure out transportation, all that. Traditionally, you'd be jumping between different websites, different apps. But with multi-agent orchestration, you could have a team of AI agents working together behind the scenes to handle everything.
So I just tell my AI travel assistant what I want, and they take care of all details.
Exactly. And each agent would be a specialist in its own area. You might have a flight booking agent, a hotel booking agent, a transportation agent, all working together.
That's like having a whole team of personal travel agents. But how do you make sure they're not stepping on each other's toes? How do you avoid conflicts?
That's where the orchestration system comes in. It's like the conductor. It assigns tasks, monitors progress, and resolves any conflicts.
So it keeps everyone on the same page, playing the same tune.
Exactly. And as the number of agents and tasks grows, the orchestration system becomes even more important.
This sounds really powerful. But can you get into the technical details a little bit? How does this orchestration system actually work?
The details can vary, but the core idea is to have a central hub that can communicate with all the agents. It might use a messaging system or an API to send instructions and receive updates.
So it's like the command center, dispatching orders and getting reports.
Exactly. And the orchestration system can also monitor how the agents are doing, see if there are any bottlenecks, and, take action if needed.
Like a project manager, keeping everything running smoothly.
Exactly. And as the project gets more complex, that project manager becomes more and more important.
This is really impressive. It sounds like multi-agent orchestration could be a game changer for managing all sorts of complex tasks.
It could be. And the applications go way beyond travel planning. Think about healthcare, coordinating different specialists, or finance, managing complex transactions, or manufacturing, optimizing production lines.
The potential is huge. But as always, I have to ask about the challenges, the risks. Are there any ethical concerns with this kind of system?
Great question. As with any powerful tool, we have to be thoughtful. One challenge is making sure all the agents can communicate effectively. They have to speak the same language, so to speak.
So they're all on the same page, using the same terminology, data formats, all of that.
Exactly. Otherwise, you get confusion, errors, things break down.
So how do you solve that?
Well, one way is to set clear standards for communication, maybe using a common data format or, a shared vocabulary that defines all the key terms,
Like a universal translator for AI agents.
something like that. And another challenge is managing the complexity of the orchestration system itself. As you add more agents, more tasks, it can become really difficult to manage.
So it's like saying that conducting an orchestra is a lot harder than playing a solo instrument.
Right. You need good software engineering practices, good tools to keep everything organized and running smoothly.
Makes sense. What about the decisions the system makes? If it makes a bad call, how do you figure out who's responsible?
That's a tough one. Sometimes you can trace it back to a specific agent, a specific line of code, but sometimes it's more emergent. The decision comes from the interactions of multiple agents, so it's harder to pinpoint responsibility.
It's like with a flock of birds. It's hard to say which bird is responsible for the flock's direction.
Exactly. And that's why explainable AI is so important. We need to be able to understand how the AI is making decisions, even when those decisions are complex and emergent.
Transparency is key, especially when these systems are making decisions that affect people's lives.
Absolutely. We need to build trust in these systems, and that requires transparency, accountability, and a commitment to ethical AI development.
It sounds like multi-agent orchestration is a really powerful tool, but it's also a tool that needs to be used responsibly.
I completely agree. It's up to us to make sure that this technology is used for good, to enhance our lives and help us build a better future.
Well said. This has been a really eye-opening discussion about multi-agent orchestration. Thanks for sharing your insights. But you mentioned another architecture earlier that I'm curious about, energy-efficient architectures. Can you tell me more about how those work and why they're important?
Of course, as AI systems become more powerful, they also tend to use more energy, and that's a problem, right? So, energy-efficient architectures try to address that by optimizing how much computing power and resources the AI uses.
So it's about making sure that AI isn't just intelligent, but also sustainable.
Exactly. We need to find a balance between performance and environmental responsibility.
I like that. But how do you actually design an energy-efficient AI architecture? What are the key things to keep in mind?
Well, one important principle is model optimization. These AI models, especially the deep learning ones, they can be real resource hogs. They need lots of data and processing power to train and run.
So it's like saying that a big, complex AI model is like a gas-guzzling car.
That's a good analogy. And just like we're trying to build more fuel-efficient cars, researchers are working on ways to make AI models more computationally efficient.
So how do they do that? How do you make an AI model more fuel efficient?
There are a few different approaches. One is called pruning, where you basically trim away unnecessary parts of the model, making it smaller and faster without losing too much accuracy.
So it's like trimming the fat off the AI model, making it leaner and meaner.
Exactly. Another technique is quantization, where you reduce the precision of the numbers used in the model. That can save a lot of memory and processing time.
So it's like using lower resolution images, right? They take up less space, but you can still see what's going on.
That's a good way to think about it. And then there's sparsity, which is all about representing the model in a more compact way, just storing the essential information.
So it's like packing a suitcase efficiently, only bringing what you absolutely need.
Exactly. All these techniques can make AI models much less demanding on our computers, which means they use less energy.
That's really clever. It's amazing how much effort goes into optimizing these models. But it sounds like that's just one piece of the puzzle. What other things can you do to build more energy-efficient AI architectures?
Well, another important factor is workload scheduling. AI systems often have to crunch through huge amounts of data, and the timing of those tasks can make a big difference in energy
So
use.
like running your dishwasher at night when electricity rates are lower.
Exactly. The same principle applies to AI. By running those big computations during off-peak hours or when renewable energy sources are plentiful, you can reduce the overall energy footprint.
That makes sense. Are there any other key considerations for energy-efficient AI?
Hardware is another big one. The actual hardware that the AI runs on can have a huge impact on energy use.
So it's like saying a fuel-efficient car needs a fuel-efficient engine.
Exactly. And we're seeing a lot of innovation in hardware that's specifically designed for AI.
Oh, like what kind of hardware should we be looking out for?
Well, GPUs, those are graphics processing units, they've become really important for AI, especially for deep learning. And companies like NVIDIA and AMD are constantly making them more energy efficient.
So more power, less fuel.
Exactly. And there are also specialized AI chips like Google's TPUs or Intel's Nirvana processors. They're designed specifically for AI tasks, and they can offer a big performance boost while using less energy.
It sounds like there's a lot happening in the hardware world to support energy-efficient AI.
There is. And it's not just about the chips themselves, it's about how we design the whole system. Researchers are even looking at techniques like approximate computing, where you intentionally sacrifice a tiny bit of accuracy to get a big reduction in energy use.
So sometimes a good enough answer is good enough if it saves a lot of energy.
Exactly. And for many applications, that trade-off makes a lot of sense.
This is really fascinating. It seems like energy-efficient AI architectures are a key part of making this technology more sustainable.
Absolutely. And it's not just about reducing our carbon footprint. It's also about making AI more accessible to people in parts of the world where energy is scarce.
All right, so energy efficiency is also about equity, about making sure everyone can benefit from this technology.
Exactly. As AI becomes more and more important in our lives, we need to make sure it's both intelligent and sustainable.
Well said. This deep dive into energy-efficient AI has been really insightful. Thanks for explaining all of that. But I'm also curious about something you mentioned earlier. Human-centric collaborative architectures. What are those all about?
Human-centric collaborative architectures are all about designing AI that works with humans, not instead of them, augmenting our abilities rather than replacing us.
So it's about creating a partnership between human intelligence and artificial intelligence.
Exactly. It's about recognizing that we each have our strengths. We can accomplish much more by working together.
I love that idea. But how do you actually design an AI system that can effectively collaborate with humans? What are the key principles there?
Well, one of the most important principles is user-centric design. The AI needs to be designed with the human user in mind. The interactions should be intuitive, transparent, easy to understand.
So the AI isn't just a black box, it's something that humans can interact with and understand on their own terms.
Exactly. The AI should be able to explain its reasoning, provide feedback, and adapt to the user's preferences.
That makes a lot of sense. What other principles are important for human-centric collaborative architectures?
Another important principle is shared control. We don't want the AI just making decisions on its own without any human input.
Right. Got to have some oversight there.
It's all about finding the right balance. The AI should be a tool that helps humans make better decisions, not something that replaces human judgment altogether.
I like that. Empowering humans, not replacing them. What about this idea of mutual learning? Can AI systems actually learn from humans and vice versa?
Definitely. That's a key part of this whole collaborative approach. The AI should be able to learn from human feedback, get better over time. And on the flip side, humans can learn from the AI too, gain new insights from its analysis.
So the two-way street, both sides benefiting, both sides learning. Can you give me a real-world example of how that might work?
Sure. Let's think about healthcare again. Imagine a doctor working with an AI to diagnose a patient. The AI can look at medical images, lab results, the patient's history, and come up with potential diagnoses, suggest treatments.
So it's like a second opinion, but from a super smart computer.
Right. But the doctor is still in charge. They consider the AI's recommendations, think about the patient's individual needs, and then make the final call on the treatment plan.
So the AI isn't replacing the doctor, it's more like a consultant, helping the doctor make the best decision.
Exactly. And the cool thing is, both the AI and the doctor are learning during this process. The AI gets better at understanding complex medical cases, and the doctor might pick up on new patterns or insights that the AI highlights.
That's a really powerful example. Are there other areas where this human-centric AI is proving to be successful?
Oh, absolutely. We're seeing it in design, engineering, even creative fields like music and art. For example, in architecture, an AI could help generate initial designs, explore different possibilities, but the architect is still the creative force, refining those designs, bringing their own vision to life.
So it's like having an AI brainstorming partner, pushing the boundaries of creativity. This is incredible. It sounds like human-centric AI has the potential to, well, change everything.
It really does. But of course, there are challenges too. We need to make sure that these AI systems are aligned with human values, that they're not optimizing for the wrong things or making decisions that could harm people.
That's a really important point. AI needs to be serving us, not the other way around. How do we make sure that happens?
Transparency is key. We need to be able to understand how these AI systems are making decisions, and we need to be able to hold them accountable for their actions.
So it's not just about building smart AI, it's about building ethical AI.
Exactly. If we can get that right, we can create AI that truly enhances our lives, helps us achieve more, and creates a better future for everyone.
This has been an absolutely incredible deep dive into agentic AI. You've given me so much to think about. I'm really excited to see where this technology goes next.
It's been my pleasure. And remember, this is just the beginning. The future of AI is full of possibilities. It's up to all of us to shape that future, to make sure AI is used for good.
Thank you so much for joining us on this journey into the world of agentic AI. We hope you've learned something new and are as excited as we are about the potential of intelligent agents. Until next time, keep learning, keep innovating, and keep asking those big questions. The future is out there, and it's waiting to be shaped by us with the help of AI. Goodbye, and thank you for listening.